Hello everyone, welcome to my channel. In this video, I will be introducing you concepts from Chapter 2, INCOSE ASEP Systems Engineering Handbook. We will be looking at this tutorial where I cover sections from the book. We will be looking at the overview of systems, and in a while I'll walk you through systems engineering concepts and also introduce you to hierarchy. Then we have a difference between complex as well as complicated systems. This book explains about and emphasizes on it. Also, we will be looking at 7 challenges influencing systems of systems, what they are, and we will be looking at those in depth. So if you are new to my channel, please subscribe. You can look at my previous introductory videos to know more about that. So let's dive into this material. So systems is as a whole consists of elements as well as sub-elements and also assemblies. This is a definition INCOSE book explains us, and this definition has been there since 1968 or so. It's been defined by Ludwig von. So we also have ISO, IEEE and IC definitions that the book introduces. These are elements. It constitutes of all those hardware, software, facilities, people, services, and everything put together becomes a product, and that's the core of the system. So what are these systems engineering concepts? So the book goes in depth about different definitions for these systems engineering concepts. It will be introducing us to as new systems engineers or even the ones who are already familiar with. Let me give a brief one-liner for each one. So operating environment, as you may know, it's simply that where the system functions. It's a context in which we are making sure the system is functional, right? And this system boundary is almost like an imaginary boundary that separates from your system, your elements within the system, to versus what is not captured within your system. And what is the functionality of the system? Functionality of system is more or less similar to operating environment, but the only difference is you have to make sure it is operational to the user, the end user, whoever is using your product or the system itself. So that's why the name itself describes us. It's a functionality of the system. And then system architecture. System architecture is more of a fundamental concept in which you include your elements, you include your relationships of those systems, its elements, and also the principles for the design. It's a core, and it captures, hand in hand goes with your system requirements. For those of you who are already familiar and in this field for quite a while. Then we also will be looking at the engineering definition. As you may know, engineering is key for many man-made products, right? Services. So the key for this engineering is we should be able to repeat it, and we should be able to build sustainable products. That's the key to the engineering. Attribute here describes it's a property of the system. For example, you have a vehicle and its speed is an attribute. Vehicle speed is an attribute. This is some kind of parameter that you are requiring for the evaluation of the system. That's why it's an attribute. And then you have a variable, so it's almost like a symbol that you denote this attribute with. So for example, I have a vehicle speed 8 miles per hour, so I want to denote that with the vehicle speed name. That is nothing but my variable. And then it talks about measurement. Measurement is the value that you're assigning to this. It's 8 assigned to vehicle speed, which becomes that 8 is nothing but the measurement. You are measuring the system and it's evaluating towards 8. So that's the measurement. Book also introduces about the dynamic behavior. Dynamic behavior is the change over time. And then we have emergent behavior. Emergent behavior is somewhere you cannot predict the behavior of the system itself. So now comes system hierarchy. The book talks about system hierarchy. It tells us that system elements should be considered as at an atomic level, at a fundamental level. It should be individual elements. And if you have multiple systems, you have a system engrossed in another system and so on and so forth. So that's where this system hierarchy comes into effect. And you can also have systems that are not dependent on the other systems, but they are included within the subsystems. So those are also the possibilities that you can have in system of systems. And that's why you will see in my later slides that there are quite challenges that we need to face for system of systems, because how complex they are and how unpredictable or emergent behavior will come into effect. So complex and complicated, like I just said, I have introduced basic definitions because this differences talk about mainly about on the emergent behavior. So it is crucial for us to understand what emergent behavior is even prior to understanding complex versus complicated. That's the reason why I've introduced those before. So complex and complicated. So complex is more like you can create that system. It is fixed, it is predictable, and you can estimate the time, you can reliably estimate the cost, and you have the technology. All right. Unlike complex systems, the interaction is not predictable. It is emergent behavior. At least I believe complicated systems might be at least to a point where the system shows dynamic change of the behavior. Even in that scenario, you probably can predict something, but in complex system, it becomes very difficult due to their emergent behaviors. And now there are some challenges that do influence on this system of systems. And the book gives us 7 main challenges that are part of this and influencing these system of systems. So let's look at one by one. So system of system authorities is something where system have to work together as a big system, and it is very important for all those systems need to be integrated and meeting a commonized goal. That's why systems of system authority is one big challenge. And then it talks about leadership. So leadership, how do you recognize these authorities, and how are you going to provide alternative solutions to control these? So that's a big challenge here. And constituent system perspective. So in this challenge, It is more of how the perspective and limitations of one system over the other. This is a challenge as well. Another challenge here is capabilities and requirements. Of course, we do capture requirements, but how are we going to ensure all these requirements captured by each individual system will ensure we fulfill the whole entire system of system design scope? So that's another challenge. And another big one is autonomy, interdependence, and emergence. Like I just said, because of these emergent behaviors, because of this interdependency, it becomes quite difficult for us to anticipate the effects of those systems. So that is another big challenge. And the another one is testing, validation, and learning. So testing, validation, and learning becomes quite complex due to the system of systems integration. And even though we use a lot of modeling simulations for the systems, we still will be having some roadblocks or some missing pieces that are out of scope or probably missed in the analysis. So there is also system of system principles. This whole area, the system of system, is new. That's what the book explains us. It's still emerging, it's still improving, it's new to most of the engineers. So it does need more more efforts and carefulness in the planning, as well as for engineers who are doing assessment in those systems of systems. And then the book explains us about enabling systems. Enabling system is not as similar to sub-elements. It's not directly the elements of the system itself. They just help us in the life cycles. So if you have logistics, if you have some support systems, production systems, so these are just helping in the life cycle. Okay, all right. So I think we had a very good review of 5 important sections within this chapter 2, and let's give it a shot of this quiz I've put together. So you can pause the video and then make sure you answer this, and then I can show you the results. Okay, here are the answers. So you can have a look at this and see how many you have answered correctly, and let me know in the comments that if you have liked this video and thought it helped you a lot in memorizing these concepts and learning these concepts for your upcoming INCOSE exam, ASEP exam. Give it a like, share, and subscribe to my channel. I hope you guys have learned something from my channel, and good luck with your career.